The human immune system is not just a biological barrier, it is our body's high-tech adaptive software. It works as an active, intelligent network that constantly identifies, tracks, and neutralizes threats. This defense relies on a powerful two-tier strategy: the immediate innate response and the highly specialized adaptive force. The innate immune system is our rapid responder. It is the body's first line of defense, acting instantly against any recognized intruder. It begins with physical barriers like our skin and mucous membranes, which block pathogens from ever entering our system. But when a threat breaches those walls, specialized cells called phagocytes immediately move in. These innate immune cells engulf and destroy pathogens before an infection can escalate. This immediate, non-specific response is key to keeping us healthy every single day. We used to think the innate immune system was just a static, first-line defender. But as of 2026, we have discovered the incredible phenomenon of trained immunity. Innate immune cells, like macrophages, undergo a complete functional overhaul. They don't just react, they learn. Through a process called epigenetic reprogramming, the cell's chromatin structure is modified. This is essentially an upgrade to the cellular software. This upgrade allows the cell to react significantly faster and more aggressively when it encounters the same threat a second time. It is memory without antibodies. It is truly a paradigm shift in how we understand our body's high-resolution biological defense architecture. When a pathogen manages to breach our initial defenses, the adaptive immune system takes control. This is our specialized force. B cells function as our precision engineers, producing highly specific antibodies that act like heat-seeking missiles to neutralize the threat. Simultaneously, T cells emerge as the elite soldiers, performing direct, targeted combat to hunt down and destroy cells that have already been infected. Together, they ensure the infection is contained with extreme specificity, unlike the broad, sweeping response of the innate system. How do T cells know exactly what to destroy? They utilize a high-resolution verification process called the MHC peptide signaling system. Think of the MHC molecule as a display window on the cell surface. It holds a tiny fragment of a protein, known as a peptide, like a sample plate. A T-cell receptor constantly scans these windows. It performs a high-precision molecular check to see if the peptide belongs to the body or if it is a viral invader or a mutation. When a match occurs, this signaling system acts like a green light, confirming the target. It is the ultimate decision point for immune activation, ensuring the body clears only the right cells. We are entering a transformative era of medicine. Scientists are now utilizing hyper-advanced AI to map pathogen surface proteins with unprecedented precision. By analyzing structural data, these models can actually predict how a virus will evolve and mutate over the next 6 months. This breakthrough allows us to design universal vaccines that stay one critical step ahead of viral mutations. We aren't just reacting to outbreaks anymore, we are predicting them. We are entering a revolutionary age of synthetic immunology. Scientists are now developing synthetic immune circuits, engineering viral vectors to act as biological delivery systems. These vectors deliver precision genetic code directly into T cells, effectively uploading new instructions to the cell's internal software. Once programmed, these T cells become specialized hunters, identifying and neutralizing specific disease markers with unprecedented real-time accuracy. The gut is the absolute command center of our immune defenses. Did you know that 70% of immune regulation happens right here in the microbiome? We are now deploying precision probiotics, engineered tools designed to treat chronic inflammation by optimizing this vital gut immune connection. This is revolutionary health management. We are witnessing a monumental leap in immunology with the 2026 mRNA cocktail vaccines. Unlike previous approaches, these innovative therapies package multiple mRNA strands into a single lipid nanoparticle. These cocktails are specifically designed to target the conserved, non-mutating regions of viral envelopes. This strategy effectively bypasses the virus's ability to mutate and escape immune detection. The results are incredible. This universal protection technology has demonstrated a staggering 90% reduction in severe illness across diverse patient cohorts. This marks a definitive shift from reactive medical treatments to proactive, high resolution immune engineering. We are entering a revolutionary era of on demand immunity. Medicine is decentralizing, moving away from generalized, one size fits all treatments toward highly portable, personalized technology. Imagine wearing a compact biosensor that continuously monitors your internal signaling pathways. These devices track biomarkers in your saliva or sweat, specifically hunting for signs of a cytokine storm. By analyzing these signals in real time, the system can trigger medical alerts. You receive a warning notification, allowing you to take action and correct your immune response before a health crisis even begins. We are entering an incredible era where we can finally reverse immunosenescence. As we age, our immune system naturally loses its edge. But now we are looking at the heart of the problem, the thymus. The thymus is the master school for T cells, where they learn to identify threats. Over time, this organ shrinks and its function degrades. But current research is finding ways to rejuvenate it. By restoring thymic activity, we can jumpstart the maturation of fresh, potent T cells once again. It's like upgrading the body's primary defensive software to its peak performance, effectively turning back the biological clock on our immunity. We are entering a revolutionary era. The global approach is shifting away from simply killing bugs toward masterfully managing our immune architecture. By viewing our defense as an adaptive software system, we move from primitive fighting to high-resolution data management. Dr. Alina Vance notes that when we provide the immune system with the precise data it needs, it can navigate threats without causing collateral damage. This is the future: precision, resolution, and total system optimization. We are witnessing a truly monumental shift in oncology. In recent medical cohorts, targeted immunotherapy has achieved an astonishing 92% reduction in mortality when compared to traditional chemotherapy protocols. This isn't just an incremental improvement, it is a paradigm shift in medical efficacy. By precisely identifying and neutralizing malignant cells without the collateral damage of older treatments, we are rewriting the survival story for thousands of patients. Imagine a future where monitoring your immune health is as simple as counting your steps. By 2028, wearable immune biosensors will revolutionize healthcare, with 40% of the global population tracking their immune status in real time. These devices move far beyond basic heart rate tracking. They utilize advanced sensors to detect cytokine volatility, identifying early-stage inflammation before you even feel a symptom. By providing high-resolution data on your immune architecture, these biosensors empower users to take preemptive action, turning the immune system from a mysterious shield into a managed, transparent asset. The landscape of medical science is shifting. Currently, a staggering $14.2 billion is invested globally in synthetic immune cell therapies. This immense capital is not just numbers, it is fueling an unprecedented speed in our transition to active, engineered immunity. We are actively programming immune circuits to solve diseases at the source, transforming research into real-world biological solutions. We are witnessing a monumental shift in immunology. For decades, we relied on passive immunity, where we essentially provided the immune system with a blueprint or a shield to teach it how to react. But now, we are entering the era of active immune engineering. Instead of just teaching, we are actively programming and guiding the body to identify and correct its own biological errors in real time. This evolution from passive observation to active self-correction is the most exciting frontier in modern medicine, turning our internal defense into a sophisticated, adaptive software system. We are entering a new era of immunology, where precision is the absolute standard. Modern research is laser-focused on managing collateral damage. Previously, the immune system often responded with a massive blunt force inflammation, hitting both the pathogen and the innocent surrounding tissues. But now, by ensuring our immune cells operate with high-resolution data, we can guide the system to strike only the pathogen, leaving healthy tissues completely untouched. It is a beautiful shift from chaos to controlled, intelligent orchestration. This precision stops autoimmune responses and dangerous hyperinflammation in their tracks. Welcome to the training ground of the immune system, the thymus. This incredible organ is where bone marrow derived progenitor cells embark on a rigorous journey to become fully matured T cell soldiers. As these immature progenitors enter the thymus, they undergo a sophisticated education process called positive and negative selection. We are filtering out cells that cannot recognize the body's own markers, ensuring only the most precise defenders survive. Modern medical interventions are now focusing on thymic rejuvenation. By supporting this organ's vitality, we ensure a constant, high-quality supply of trained soldiers for the body's defense network, effectively reversing immunosenescence. This constant refinement is what keeps our immune software running at peak performance, managing threats without collateral damage to our own healthy tissues. A cytokine storm represents one of the most dangerous runaway events in immunology. It occurs when the immune system goes into overdrive, flooding the body with inflammatory proteins and causing systemic damage. Previously, identifying this storm was a reactive, time-consuming process. But today, we are pioneering non-invasive monitoring. By utilizing ultra-sensitive saliva and sweat sensors, we can detect rising cytokine levels in real time. This breakthrough allows medical professionals to intervene before organ failure begins. By treating the immune system like a software circuit, we can throttle back the inflammation and save lives. Think of your immune system not just as biological hardware, but as a sophisticated, high-performance software stack. It runs on genetic code, but in 2026, we are treating it like programmable logic. Through gene therapy, AI mapping, and microbiome optimization, we are now patching this system in real time. By applying these digital age updates, we ensure our immune architecture remains perfectly optimized, allowing us to manage complex threats without collateral damage. This is the new era of active immune engineering. We are no longer just subject to our immune system's natural limits. By 2026, we have the sophisticated tools to engineer, monitor, and guide our immunity with unprecedented precision. This marks a transition from passive defense to a future of proactive health management. We aren't just surviving, we are learning to optimize our biological architecture for a healthier, more resilient future.